Hi, this is the intermediate part of the Introduction to SQL Server course. My name is Farhad Eftekari and I'm the teacher of this course. Here are the links of this course that you can find the material of this course, the slides, tutorial videos, assignments, and files. And here are some typographical conventions that we use in our slides. So in the bottom of our slides, if you encounter them, each of them means something and you can get to know more about them in this slide. And here is the difficulty level indicator that we use from the easy material to the hard material. So it's up to the students that how deep they want to dig and expand their knowledge in this SQL Server topic. And here is the slide framework of this course. The difficulty indicator is going to be placed here, the slide number, the code that if you go to this link and instead of this code, enter the code of that slide, that certain slide, it will redirect you to the part of the tutorial video of that certain slide. And here's the title and this content of the slide, those icons that we talked about, section name and course name. And the content of this intermediate part of this SQL Server course are creating a database and art of selecting proper ones, understanding primary key and foreign key, working with tables inside the table, database diagram, those four important statements, query statements such as select, insert, update, and delete, and also clauses, keywords, and operators related to these statements and query. By definition, SQL stands for Structured Query Language, and as we talked earlier in this introduction part, SQL can be pronounced as SQL or SQL. Both of them are right, and it's a standard language to work with relational databases. And MS in MS SQL Server stands for Microsoft, and if you encounter SSMS in our slides, it stands for SQL Server Management Studio, which is a very beneficial tool to work with SQL Server. And DB also stands for database. To create a database, there are two different methods that you can use. First, by using the syntax here, you can write it and create your database. Or with a graphical interface, you can just right click on your server in the Object Explorer and just select create or new and then enter the name of your database there and make sure the database be created. But sometimes some servers does not allow you to directly create your database. So you can also create try by yourself to see if it works or not. And sometimes there are some CMSs like web hosting CMSs portals that you need to go and log in their own control panel, whatever it is, and then on the web view or by using this portal, you can create your database and then assign a user and password to it, username and password to it, that database, and then connect to your database and work with it. And if you want to remove a database, you can also use these two methods by using the syntax, which is drop database, your database name, or using graphical interface by right click on your database and select delete. And always remember to have an updated backup from your database before you're removing it to make sure you're not losing any essential and important information there. Alright, now we reach to a very interesting and beneficial topic, which are data types. I selected the topic of this slide, data types and art of selecting proper ones, because it's a really important topic. This is where makes the difference between a normal database admin or developer or an advanced and a skillful database developer. So this is a topic that make sure you learn as much as you can and understand the difference between data types, because it will come to you and it's going to be really useful and beneficial for you, and you have this knowledge to use when you're developing your database and tables. There are reasons that we have these data types. I want you to think for a moment for yourself or with a pair, if you have one, and just discuss that why we created and we are using data types, and what are the benefits they are giving to us. I'm gonna right away start with teaching the material. You can just pause it if you want more time. I'm not gonna waste your time and mine by just being silent. So you be in control of the this video. You can, whenever you want, you can pause it and give more time for yourself. Uh, let's see, why do we need data types? First of all, it's a question of performance, because when you are working with a specific size of data, and just imagine you have like thousands or millions of rows of information, and you assign a sufficient amount of size to this column of information. So when your database is reading your information, for instance, if it's a number, instead of reading like 10 millions of rows of 2 bytes of data, it's much easier for uh, performance of your server rather than millions of 4 bytes of records of data. And the second is the question of space. Just imagine you are storing millions of rows of information, and then by selecting a proper data type, you make sure that you're not going to overuse the resources of your server, and then you're going to save much amount of space you need, because you know that more than some numbers or some characters, you don't need to store in your database, and in this way you're gonna save a lot of amount of space on your database. So in this case, it's also really beneficial for you to select the right and proper data type for your information. And at the end is the question of error handling, because you know there is a span that you selected your data to be stored in. So you make sure when you're entering those information in your database, it's going to be somehow between this minimum and maximum of numbers or characters or whatever you're defining. So these are the reasons that we created and using these data types. And let's see what type of data types we have in the SQL Server to use. First, there are numeric data types, and then we have strings data types, and date and time data types, binary, and finally the other ones that got left, and we cannot put them in any of these categories, but they have the category of their own. Here are the numeric data types in SQL Server. As you can see in this table, there's this data type name you can see here, and they have a minimum and maximum number, as you can see here, and also the size for each row of a column of information you're gonna store in your database. So here's that thing that I told you about space saving. So when you know that you're gonna store some numbers that's not gonna be greater than 2 billion, then by using this big int, you're gonna save like more information there. So then you're gonna use much more resources from your database. So we have big int, which is a very big span for storing a number there, and then we have int, uh, lower than big int but greater than a small int, which is between this number and this number, 32,767, and it stores 2 bytes. And then we have tiny int, which is from 0 to 255, and then we have bit, which is either 0 or 1. So it's like for situations, for instance, you want to see if something is on or off, or true or false, or even 0 or 1 as a number. So you select this data type there. And there's something interesting about this bit data type. As you can see, I didn't write it here, and there's a description here that why I didn't write it. So for each 8-bit that you use, database gonna use 1 byte. So if you use 1, it's gonna use 1 byte, 2 1 byte until 8. So if you're using 8 columns of bit data type, 1 byte gonna be stored. And if you add one more and it reached to 9, then it's gonna use 16 bits. So this is the way they store the information there. And also we have decimal and numeric data types, and also money and small money, which mostly used for bank transactions, uh, the balance of your bank account if you're creating some accounting application or software. And also we have this approximate numeric data types, which are float and real, and these are the span of those data types and the size of them as well. And here are some examples of these numeric data types. Let's work them out together. So when you are selecting a numeric data type for your column, there are things that you need to consider. First of all, what is the range of the number you're going to store there? And second, is it a whole number or decimal number? And finally, is it a money type of number or regular number? So these are the questions you need to ask from yourself to select the right and proper data type for your numeric formation. And here are some examples. Let's see, if you want to create a database and we have a table for information of people living in Finland. Let's see what are the proper data type for that. First, let's see what is the population of Finland. If we can search for it, and let's see. It must be something below that 6 million. Yeah, 5.4 million. So let's get back to our data types, numeric ones. 5.4 is definitely something that is below than 2 billion and greater than 32,000. So the most proper one is selecting this int data type. If we select a small int, we're gonna run out of numbers. If we select big int, we are overusing the resources of database. So definitely by selecting int as a data type, this is the best choice for that. And also people living on Earth, let's see how many people are living on the planet Earth. Yes, 7 billion. And let's get back to our data types. Let's see what are the span numbers there. So 7 billion is definitely greater than int, which is up to 2 billion. And big int is also sufficient for it. It's a very large number. So we definitely have to select big int for our data type here. Yes. And also for a balance of bank customers, which is something below 100 million, money would be sufficient. And if we have some status tracker of a lamp to see if it's on or off, then bit would be a good choice for us. And also imagine we have action types of some events, and we have up to 100 action types. So the good choice for this data type is tinyInt, because tinyInt can be from 0 to 255. So this is a good choice to select from. And now we have strings data types. We have char, we have varchar, varchar max, and text. And there are two types of strings. We have character strings data types and Unicode character strings data types. Uh, First, let's see what are the difference between type of data types there. Because as you can see, they are identical. So the char is a specific number of characters. So you can select char when you know exactly how many characters you have in your information that you want to store. Otherwise, if you want to store more characters, it doesn't let you, and it only stores that amount of characters. If you are storing less characters, then for each character that you didn't provide, the database itself going to store a blank space. So you don't really need to do that for your information. Varchar is something which is more practical when you don't know the exact length of your characters or word or anything you want to store. Var stands for variable, and you can define also the maximum number of your varchar by selecting like varchar 100. It means that up to 100 character you can store. If you store like 50, then 50 gonna be stored, and it's only gonna use that space for storing those 50 characters. And we have data type text, which we barely use. It's somehow outdated to use also, and 2 billion, more than a little bit more than 2 billion characters you can store there. And also for Unicode characters, we have nchar, nvarchar, nvarchar max, and ntext, which this n means that's the Unicode data type. And let's see what's the difference between Unicode and non-Unicode data type. Some languages, when you want to store their text, are non-Unicode, and some are Unicode. Mostly the ones that's coming from Latin letters are non-Unicodes, and the other ones such as Farsi, Arabic, Chinese, Nepali, Hebrew, Greek are Unicode. So if you want to store some text or information, uh, especially if you are working and providing some services for the people in those countries that they are using these languages, you need them. But if you already sure that only English or Finnish or Spanish or German or Swedish or French languages are being used and the text is in their languages, then you can use this non-Unicode ones. And if you select these non-Unicode ones and somebody provide some characters or letters coming from these Unicode ones, then the database gonna store instead of those characters a question mark. So it's gonna be not very beneficial and useful text for you to use. So make sure to select the right one between non-Unicode and Unicode when you are selecting your data type for your tables, columns. And here are some examples for a strings data type. So there are things that you need to consider when you are selecting among these strings data types. First, you need to ask yourself, is it a Unicode or non-Unicode data type? Then is it a fixed number of letters or characters, or it's not fixed and it should have some maximum number of some limitations for storing those characters? And here's an example that sometimes, for instance, we would like to store some information which we already know is the 3 English characters. So we already know this length of this data type is 3. So char3 is the best choice in that case. And we also would like to, in this case, store some messages from our users, which can be up to 255. So it's not fixed. Somebody can provide like 2 characters, someone can provide 255. So the right proper one would be this nvarchar 255, or if we know this non-Unicode ones, then we use varchar 255. But in this way, we make sure if someone is writing the messages in Arabic or Farsi or Nepali or the other languages, then the database will store the exact information there. We would like to have a column with storing email addresses, so we use varchar 100. So most of these email addresses are less than 100. First name in English, then varchar 50 would be sufficient, in my opinion. And the other data type that we regularly use is this date and time data type, which also have some data types in this category. We have date time 2, a small date time offset, and time stamp, which these two you can more search for yourself to understand the difference. We usually use these ones, especially this small date time, which is often we use. So let's see what are the difference between these ones. For date time, the limitation is from this exact date until this exact date. So we can store something between, some dates between these two, and it's going to store 8 bytes. For date time 2, it's from 1st of January 1 until 31st December of 9999. And the difference between date time and date time 2 are two things. First, this span and limitation, and the other one is the accuracy of them. So for date time, the accuracy is 3.33 milliseconds, but for date time 2, the accuracy is 100 nanoseconds. So sometimes imagine you are storing the date and time of an experiment in a lab, and it's important that exactly based on this milliseconds and nanoseconds, you store the exact value of the date and time. So it's not always for us that the accuracy is up to seconds is important. So it's up to your case, up to your project and application. So here is a good example of having this choosing between these two data types. And also we have this small date time, which most of the times we use in our applications, and it uses less amount of space, and you can store values and date time between 1st of January 1900 and 6th of June 2079. And also we have this date data type, which can store a date value, and also we have this time data type, which can store only time part. And here are some examples for this date and time data type. So when you want to select the date and time data type, there are some things to consider. First of all, does it include date, and does it include time? What is the range and the accuracy? And by considering them, here are some examples, and let's see. The date and time of a course's sessions. So a small date time would be sufficient enough for us. Date of the events. So only we are looking for storing date parts, not times. Saving date and time of experience in the lab, as I already explained. So date time 2 would be enough for us, and because as we discussed, the accuracy is 100 nanoseconds. And here are binary data types category, which we have binary, var binary max, and image. So your database can also store files and binary files inside of it, which is not a very logical thing to do, because most of the times the space of your database is much more valuable than the space of your web hosting. So by using this data type, you may store so much information, and you're gonna make your database size very low. Store your files in your web server, and maybe the URL and a link to your file in your database, and then you can easily point them together and use your file like this. Yeah, this was the point that I described for you to use this binary data type. And finally, we have these data types that got left from those categories. We have SQL variant, unique identifier, XML, cursor, and table. Uh, you barely encounter situations to use them, but you can also search by yourself to see what are the differences and what are the cases that you sometimes need to use these data types. So let's have a hand-on experience of these data types, and also try to think by yourself, or if you have a pair, that is there any other data type that you can think about that we didn't discuss or talked about and it's not in SQL Server. It's a good example and good practice for you to get familiar with these data types and to see if something in your mind is already there or not. uh, yeah, for a moment think about that and try to find some answer for that. And now let's get introduced to the concept of primary key and foreign key. By definition, a primary key is used to uniquely identify each row in a table. And also, foreign key is a column that references a column of another table. So as you can see here in this example, we have a table named customers, and there are many rows inside of this table. We have customer ID, company name, contact title, and the other ones. And also for this table, which is the name is orders, we have order ID, customer ID, and employee ID. So if you want to uniquely identify each rows of this table, we have to have a primary key for this table. We select customer ID as a unique primary key and unique key for this table. So each customer has to have a unique customer ID in order to be identified. And with that customer ID, we can easily get access to the other information of this row. And also here in this orders table, we have this order ID as a primary key, and exactly the same about these customers. With that unique ID of order ID, we can get access to the other information. And here, this customer ID is a foreign key in this table, which points to this other table, which customer ID here is a primary key. So we can have many orders from a customer, and by defining this customer ID, we can easily link these tables together, and by this customer ID get the other information of this customer from this customer's table. So that's the whole purpose of using primary keys and foreign keys in our tables. And let's see what are the differences between primary key and foreign key. In my opinion, on the previous example, you clearly understood the differences, but let's go on and read about them and also get more familiar with them. So primary key uniquely identify a record in the table, and foreign key is a field in the table that is primary key in another table. Primary key can't accept null values because it's like pointless to have a unique identifier which is a null value. But foreign key can accept multiple null values. By default, primary key is clustered index, and data in the database table is physically organized in a sequence of cluster index. Foreign key do not automatically create an index, cluster or non-cluster. Can manually create an index or foreign key. With indexes, we will fully get introduced and understand them in the advanced section. You can find that topic there, and here you just need to understand that primary key indexes can be created automatically for them. But for foreign key, database does not do such thing. But later we will get introduced to them more deeply. And in the end, we can have only one primary key in a table, and we can have more than one foreign key in a table. And that makes sense because we need a unique identifier to represent for a row, but for other column information, for instance, as that orders table that we had, customer ID, employer ID, these ones can be primary key of other tables, but we really don't care. Here there are foreign keys, and we can store as many foreign keys as we want in this uh, column of in this table of information, this row. But as I said, for primary key, it needs to be unique. Right, now let's create an example together. So let's create some table here. The first one, I'm going to call it customers. So the first row going to be customer ID, and it's a primary key of this table. And then I'm going to have the orders table and have this order ID as the primary key of this table. You have customer ID who order this order. And then the fourth table gonna be products. Right, now I have four tables here. So let's point the connections together and link these tables together, and let's see how they can be connected to each other. So I'm going to point from the foreign key to the primary key of these tables. So here from customer ID, I pointed out to this customer ID of this customer's table. Then we have product ID. We have employee ID. And that's it. So in this example, you can see on this products table, we have product ID as a primary key here. For employees table, we have employee ID as a primary key. For customers table, we have customer ID as the primary key. But here, for orders table, we have order ID as a primary key, but customer ID, product ID, and employee ID are the foreign keys, which are the primary key of the other tables. So here we were able to easily link these tables together on the paper, and then later for the when you get to know about these statements, query statements, then you will understand and get familiar with how on the queries we can link them together. All right, and then later we're gonna know how we can create these primary keys and foreign keys on our tables. Here are some hints that later we can use. All right. Now we got to the point that we're going to work with our tables. We will understand how to create a table, how to modify a table which already been created before, how to delete a table or a column from a table, and how to delete tables data. To create a table, there are two methods that we can use in order to do that. First, we have this SQL create table syntax, as you can see here as an example. We have this create table, the table name, and then we have to mention the columns, and then right after the column name we have to mention the data type of that column, and mention them one by one until the last one. And in this way we're going to create our table using a SQL create table syntax. And the other method is using this SSMS graphical interface. You need to connect to your database. You need to select your database, and from a tables section you have to select new table, and then enter the information related to your columns, and then save your table and assign a name for it. So let's take a look at SQL Server Management Studio. I already created this test1 database here. So you open your database, and then here we have tables. As you can see here, it must be empty. Yeah. So you right click on your table section and then select new, and then table, and a window gonna pop up soon, and then after that you will be able to enter your columns name information. So let's create a table. For instance, for example, some people living in Finland. We have user ID. I'm going to select the data type int for it. And then we have first name. Let's mention them all of this column and then select the data type for it. Last name and email age. I'm going to select varchar here and limit to 50 characters, so the names must be written in English or Finnish. For email address, I'm going to select varchar 100, and for age, tiny int would be sufficient enough, because tiny int has the limitation of 0 to 255, if you can remember. So I'm not going to let users to enter database to assign a user ID as a null here. So I uncheck these allow nulls here, but all the other columns can be null values. And also I'm gonna select and press this primary key here. So database gonna select this column as a primary key. And also I'm gonna let the database itself to assign values to this user ID by going down a little bit here in this column properties, and in this identity specification I'm gonna select yes for his identity and increment by 1. So in this way we're gonna give this task as a responsibility to the database to add and enter values to this user ID. And let's save this database. I'm gonna select the name users for this table and save it. And always remember, after creating your objects, you have to refresh that part here. So by itself, the database will not show it to you, SSMS, because it's not like Adobe Photoshop application that instantly shows you the modifications, because whenever this application sends some command to the database and return values, it takes time and also using resources. So whenever you need them, you have to just right click by yourself and select refresh, and then SSM is gonna return the updated and refreshed values for you. So here is our table that we created using this graphical interface. And now if I right click on it, I can select values inside of it, rows inside of it, which is already nothing there. Or I can select this edit top 200 rows to insert some value by myself inside of this table. So let's see how it works. So as you can see here, because now it's database responsibility, we are not allowed to enter values here. But for the others, we can provide information there. So now I added this row here, and now you can see the database itself assign user ID as number 1 here. So now we got familiar with how to create our database tables using this graphical interface, and how we were able to insert some rows of information there by right clicking on our table and using this edit top 200 rows, as you could see here. And that was it. So you can also create your own table by this example. In the future slides also we're going to use as example to work with your statements and as an example there. So make sure to create this table by yourself, and let's see if you're able to do that. And finally, here are some constraints that you can use when you're creating a table, especially using those that syntax that you were get familiar with. We have not null that you already know that when you select a column as a not null, then you have to definitely insert some values for that column when you are inserting some information in that row. And also we have unique keyword, which is obvious by its name that the value inside of that column must be unique comparing to the other rows. We have primary key. We can select a row as a primary key, and it's only can be up to one column. And also we can assign a column as a foreign key, and it can be as many as we want. We have check that it checks some conditions that you want to apply for the value of that column, and also if you want to assign a default value to a column. So sometimes you have a default value, and when you don't mention values for that column, when you're inserting information there, the database itself gonna insert that default value inside of your column. And we have auto increment that we also use that by graphical interface to add values for our user ID, but also you can use this constraint for your syntax. Now you can also search online and see how you can use and consider these constraints while you're creating a table and find the examples for that. And to modify a table, there's also two methods that we can use. First, we can use this SQL alter table syntax. So to add a column to your table, you can use this alter table, your table name, and then add the column name and the data type for that column name. And also to modify a table, you can also modify a column. You can also use this syntax as alter table, your table name, and alter column name data type. So alter stands for also another meaning of alter is change or edit or modify. So whenever you see this alter keyword, it means that this object, which the type of the object is this keyword, is you're looking for to modify it or change it. And the other method is also using this SSMS graphical interface. You need to right click on your table and then select design view, and for adding a column you just insert a column there, or for modify it just select a column and then modify it. So let's see how we can use this graphical interface in order to add or modify a column inside of our table. So we have this design here. If you right click on your table, so based on the editions and versions of your SQL Server, these words can be slightly different, but if you go and you can easily find, for instance, previous editions it was design view and now it's design here. So now when I select it, the columns of that table are going to be shown to me. I can just select one and delete and then save it, or I can just modify the previously created columns there, or I can just add one more column here. And then finally save, and then the table is going to be affected based on the changes I made to this table. All right. And to delete a table's data, you can use this syntax, truncate table, table name, and all of the data inside of your table going to be removed. Or you can just right click on your table and then select this edit top 200 and manually remove the rows one by one there. And to delete a column, you can also use this syntax here, alter table, table name, and then use this drop column keyword here, and then mention the column name. Or you can use SMS graphical interface. Uh, just right click on your table, select design view, and then select a row, a column, and then delete it. We already did that, but let's do it again. Let's see if we are able to delete one. So I already right click on this table, select design, and then select the column that I'm looking for to delete, and then press delete. And then finally save my modified table. And now it's saved. And finally, to delete a table, you can also use this SQL drop syntax. As you can see here, drop table, table name, or just right click on your table and select delete. Let's also try that. I'm going to right click on my table and then select delete. And then select OK. So now the table is gone. And also you can use this database diagram in order to have a diagram for your tables inside of your database, connect them together based on the primary key and foreign key they have. And it's a very beneficial tool to use. Sometimes you would like to have a screenshot of your tables for your documents or represent it for your presentations. So here is this tool that you can use in order to get the best out of this database diagram, and there are some steps you need to follow in order to create your database diagram. First, you need to open your database and then find this database diagram and then select new on your database and then select your tables and draw the connections among your tables by selecting those primary keys and then connect them somehow to the foreign keys of your other table, and then save your database diagram. Alright, now let's get familiar with these four important SQL statements. We have select, insert into, update, and delete. Select a statement. By definition, the SQL select statement is used to retrieve records from one or more tables in your SQL database. And also here is the syntax you have to use in order to use this select statement. You have select, the expression, and the columns that we are looking for to get from the table. And you have this from table name. And if you have some conditions, we can apply here and receive that certain rows that we are specifically looking for. Here are some examples about this select statement. As you can see here in the first example, there are this customer name and city column names that we mentioned here. So by using this select statement, we are receiving these two column names from this table. So you can mention as many column names as you want, one by one, and with comma between them. The last one obviously doesn't need a comma. And if you want to receive all of these columns of this table, we can mention all of them, but there's also one other way we can do that. We can use this star sign, and by using that, the database will return us all of these uh, column names and records with this column information returned to us. And also we can combine some column together and get them by another name. For instance, we have this F name and L name, which stands for first name and last name for the customers in this customers table. So we are joining them together and bringing back this C name as a customer name for us. And as you can see here, we have this plus sign and we put one space between them, so make them more readable. And also, if we have a certain column in different tables, imagine we have city in customers and we have city in employees, so we can rename that column when the data is being retrieved to us as another name. So now we are calling this city column as customer city. And also we have some examples that you can use on your own database. Make sure to have a hands-on experience and using these examples on your own tables. And we have the concept of join. Sometimes we are looking for joining two or multiple tables together. So SQL join clause is used to combine rows from two or more tables based on a common field between them. So this is where also this primary key and foreign key can be useful for us. As I mentioned earlier in this primary key and foreign key slides, you can join the tables together from a foreign key to the primary key of the table and bring a whole uh, row with all of this information to yourself. And we have different kind of SQL joins. We have inner join that returns all rows when there is at least one match in both tables. We have left join, return all rows from the left table and the matched rows from the right table. Right join is the exact opposite with left join, so return all rows from the right table and the matched rows from the left table. And full join, which returns all rows when there is a match in one of the tables. And always be cautious when you're using join because it completely affects your database performance. So make sure to avoid using them where it's not necessarily. And here also the syntax for using those different joins. So here is this inner join that if we have information in this table and on this table too, we are looking for the ones that are somehow one record is the same. So as you can see here in this example, we are selecting as usual the column names we are looking for from this table, and we are joining table 1 to the table 2, and on this column name that we are looking for. So basically this could be the primary key and the other one could be foreign key that we are joining this table somehow together. And we have left join, as you can see here on this figure here. The whole information from table 1 is being retrieved and also the ones that is kind of match with table 2. And here is the syntax that you have to use in order to use this left join, and here is the difference with left join here. And also right join, which is kind of very similar with left join but the opposite direction. And here is the syntax that you can use in order to use this right join. So the only difference is this left and right keyword here. And finally we have this outer join, which brings us the combination of these results. And here is the syntax you have to use, and this part should be full outer join. So this is the same, the column that we want to get from, we have to select one table as the primary one and then the other one, link it to the other one, and this is the part that you can link these tables together by these columns. So definitely the data type of these columns should be the same. And here is all the possible joins that you can use in SQL queries. Alright, now let's see what is union. The union operator is used to combine the result set of two or more selected statements. Notice that each selected statement within the union must have the same number of columns. The columns must also have similar data types. Also, the columns in each SQL statement must be in the same order. And here is the syntax that we have to use in order to use union. So we have this table as a table 1, and we have this table 2, and we are joining them, linking them somehow together. But as I mentioned here earlier, the column numbers must be the same, and the data type of each of these columns must be the same. So when you are unioning them somehow together, they have to come alongside each other. Now let's see what's the difference between join and union. I want you to search online for yourself to find it with yourself or with your pair, and I can do the same also. Let's see, let's search online together. I really recommend you to always, when you have these problems or questions, always try to search online by yourself. All of this material are in these websites online for you to use and enjoy. So make sure to fully understand how to be able to look and explore for your questions and problems or expanding your own knowledge. It's a very essential knowledge for you to have. Uh, if you know how to look for your information that you're looking for, then the sky is your limit. You can just dig deeper and just try to expand your knowledge. So make sure to get the best out of this online material by using the search engines. Alright, let's search for the difference between join and union. Alright, let's see the first result that came here, and it's from the year 2009. So someone already asked this question that we are looking for, that what's the difference between join and union, and this guy very nicely described this difference. So as you can see here, uh, in this example, it's using union, and there are two rows of information coming alongside each other. And here, as you can see, they're using join. So this is the same row, and it combines two columns here. But this one, there are two rows, and we have one column here. So in union, we have the same number of columns and the information coming alongside each other. But in join, there is a same single row that these columns of information coming as a columns in a included in that certain row. So here was the difference between join and union. So they are totally different, and their applications are completely different. All right, now let's get familiar with this insert statement. By definition, the SQL insert statement is used to insert one or more records into a table. And here is the syntax that we can use in order to use insert into a statement. So we have insert into the table name that we are looking for, insert this information inside of that, the columns that we want to provide information, and then this values keyword, and then the same order that we mentioned these columns, we provide values in order to put in this table. And here is also some examples that we can see for this insert into a statement. As you can see here, we have this insert into the table named suppliers. So we have supplier ID and supplier name, and here is also the values we are providing for them. So we have to always provide and mention the columns that we are not allowed to insert null values inside of them. So we have to definitely insert some value inside of those columns. And on this Other example you can see here, we have also this insert into suppliers. It's a very advanced example. I don't want to make you confused or something, just wanted to tell you that how interesting and how practical these statements can be somehow combined together. So we have this insert into suppliers, and these are the column names, and we are getting the information and values by using this select statement here, and we don't need to provide this values keyword here also. And as I told you, be aware of not null fields. If you do not mention those not null columns or fields, then the whole task would not be compiled and the database will return an error to you. You can also try for your own to see if you're able to use this insert into statement on your sample tables. Alright, and now we have this updated statement. By definition, the SQL updated statement is used to update existing records in the tables. And this is the syntax that we have to use in order to use this updated statement. We have the keyword update here, and then the table that we are looking for to update some information of that table, and then this set keyword, and then mention the column names and then values that we are looking for to assign to those columns. And if there are many other column names, you can alongside each other mention them. And if we have where condition here, we need to provide what is the exact row that we are looking for in order to set the value. So be careful if you don't provide this where condition, all of these rows of information of your table will be affected and their values will change. Here is also some examples for this updated statement. In the first one, you can see it's update customer. So we are looking for to update some information and some rows in customers table. And then we have this set keyword. So we are assigning first name John and last name Smith to the customer whose the customer ID is 1. And in this example also, as you can see here, we're combining the select and update queries together. So we are updating customers table and we are setting the value of city, uh, the exact value of the city of customer ID 2. So this selected statement goes and get the value of city from customer ID 2 and set the customer ID number 1 city to that value. And in this example, all of these rows of information and customers table, their first name and last name is going to be changed as John and Smith because we don't have any where condition here. You can also test by yourself and try to see if you are able to use this updated statement on your sample tables. Now we get to this last statement, which is deleted statement. By definition, the SQL deleted statement deleted one or more records from a table. And here is the syntax that you have to use in order to use this deleted statement on your table. You have keyword delete from which table. You have to mention the table name and have some where conditions here that tell this query that what are the specific rows that you are looking for to delete from that table. And here are also some examples for this deleted statement. As you can see here, we have delete from customers table, and we are looking for the customer, which is the customer ID is number 1. And here is also, we are deleting almost all of these rows of data inside of this customers table. So be careful about not using this where clause. You may kind of like remove all of your rows inside of your table. And then here we also have delete from customers table, and we are looking for customers who their city is Helsinki and they are 18 years old. So as you can hear, we have two conditions applied for this where clause. And you can also try on your sample tables to see if you're able to use this deleted statement. Here are also some clauses, keywords, and operators for this SQL statements where you can use. We have where, we have distinct, and or, and order by, top, and group by, which individually we're gonna get familiar. So for where, there are some tips that you have to always take care of and be careful. For instance, by using where for your indexed columns, which we later going to be introduced in the advanced sections, then it's going to make much easier for database to find the rows. Later we're going to talk about them. But here, as we had in these two examples earlier, we can have multiple conditions for this where clause that can be used for your SQL queries. And here are some operators that you can use as any, like they're so familiar with, and mm, identical to some programming language. So this one is for equal and this one is not equal, and greater or less, or greater than or equal, and this one less than or equal. And also these three, which you can also search online and find the examples that how they use them. They're really practical in some very rare cases, but mostly these are the ones that you're mostly gonna use on your where clauses. And the other one is distinct. Distinct is really practical. Imagine you have a table named customers, and there are many of them, and they are all coming from different cities. So you want to mention and you want to get the list of cities, but only repeat each city once, not twice, not more than one time. So you use this distinct keyword here, uh, then you make sure that all of these cities are being listed, but only once, and by using this distinct keyword. And also you can use and or, just like any other programming languages. So in this example, as you can see here, and we talked about earlier, we have two where conditions. First one, the city should be Helsinki. Uh, Make sure that if you are looking for uh, word or character, you have to always put it in a single quotation here. Uh, that's the way it has to be. And also we have age equal to 18 as a number, so you don't need to put a single quotation here because that way that's gonna be counted as a string. And also we have or here we are using two conditions, and we are looking for customers who are living in Helsinki and the city is Helsinki, or they are 18. So any row that's going to be returned to us that any of these conditions are true. And here in the last example, which is a little bit more complicated than these first two, is we are looking for the customers who their city is Helsinki and their age is 18, or their country is Finland. So if we want to this part to be true, you are putting it into parentheses, and this condition has to be true, either this one or this one. So that's the way it has to be done. You have to put both of these conditions in the parentheses and use this or here. So as you can see here, this where condition can be, where clause can be really complicated and really interesting to use. And if you learn how to properly use it, then you can easily find the rows that you're looking for your SQL queries on your tables. Now we have this order by keyword here. So let's see how what is the purpose of using this order by. So in this example, we have a regular select statement here, and we are looking for the customer name and city columns of this table customers, and we want to sort them based on the name of the customer. So we are using order by customer name here. On this other example, we want to order them and sort them from Z to A. So if we mention DESC stands for descending, then it's going to be ordered in the opposite direction and the opposite way. But if we don't mention it, or if we write ASC, then it's going to be sorted from A to Z. And here in this other example, we have customer name being sorted out from A to Z. And then if any of these rows has identical customer name, then we're gonna sort them based on this city value from Z to A. So we can use multiple conditions for this order by as well. Make sure to also use this order by keyword on your tables and queries to get the best out of them and completely understand how they work. And now we have this top keyword using in our queries of our database. So we are gonna select the first two row from this customers table that has been ordered with this customer name. So we use top two or top three, top one, as many number as we are looking for in our queries. And also in MySQL, we have to mention at the end of this query limit and the number that we're looking for. And also for Oracle database, row num less or equal to 5. So this is a difference between using this top in MS SQL and MySQL and Oracle. And also make sure to use this top keyword on your queries and your sample tables so you know understand how they work. And finally, for group by, as you can see, here's the syntax you have to use for group by. So let's see what's the purpose of using group by. Imagine you have a table, your table is order details, and you have some columns as department and sales. So for each order, you mention the department name. Imagine we have a department of clothing, department of like electricities, all of this department of this shop, and then the number of the sales that order has. And you want to sum the total number of sales for each department. So you're grouping them by this department name and get the number of total sales by using this sum built-in function, which we in the advanced section we're gonna use and get familiar with, and name it as a total sales column. So this was an example of using this group by, but it's a very advanced part of this queries. So you just need to get familiar with them and just understand what's the purpose of them. And on your own, you can just create a table just like the one that I created and then use this group by and see how it works. And here is also some links that based on the topics that I mentioned here, you can visit and dig deeper for expanding your knowledge and find more information to learn. Now we reach the end of intermediate part of Introduction to SQL course, and the topics we covered were how to create and manage a database, and then we got familiar with data types and different categories of them, and then we introduced to primary key and foreign key and their differences, and then how to work with tables, how to create them, how to modify them. Then we got introduced to database diagram, and we worked with those 4 SQL important statements that were select, insert into, update, delete, and then clauses, keywords, and operators related to those statements. So that was the whole topic of this part, and See you in the next slide and hope you had a nice time in this part of the course.